Hello and welcome to my video, lesson 1.5, Geometric Infinite Series. Key here is infinite. So there are two types of infinite geometric series, convergent and divergent. So let's try to remember these as completely separate topics almost. Convergent and divergent. I'm going to do green and red for Christmas because that's the time of the year right now for me. But also to just label each of them distinctly very different. So when I talk about divergent, I'm going to use red. So we're going to look at divergent first. Red because divergent is bad. Divergent means that we cannot calculate the series. Okay, so it's going to, well, let's go into it. Okay, so divergent series is where r is greater than 1. Or greater than, like as in a negative value is bigger than, so less than negative 1. Okay, so either r is less than negative 1 or it's bigger than 1. So if you think about a number line, this is for r, right? Okay, 0 is in the middle. This point here is negative 1. And everything past that point, okay, anything past this point, let's try to use a, there you go. Anything past this point is going to be problem, but not including that point. Okay, over here we have positive 1. Anything past that point, but not including that point, is going to be a problem. So it's just the stuff in between that will be convergent. We'll look at it in a second. Okay, so for example, we have this divergent series, times 3, times 3, times 3. The value is 3, so it's somewhere over here, right? Okay, and because there's this dot, 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 it's infinite. Okay, it's getting bigger and bigger and bigger. And so, as you add each term, it just continues to grow in the positives or negatives, whatever direction that it's going. So, if it's over on this side, it'll be positives, positive infinity, I guess, and this side will be negative infinity. So as you add each term, it just continues to grow in the positive or negative. So our first term, well, we're just adding it by itself. Our second term, we add the first two terms. The next term, we add that plus the 9, so 13. Then we add another 27, so 30, 40. Then we add 81, so 121. And you'll notice that this pattern just continues to grow forever and ever. If you went to infinity, it would be infinity. So we actually don't talk about infinity too much in this course, so what we say instead is that it is undefined. Kind of like if you divide by 0, right? This is undefined. It's the same sort of idea. Okay, so this is undefined. We don't like it. It'll get you an error in your calculator because it just gets so big so fast. It's undefined. Okay, a convergent series, on the other hand, lucky for us, we got to switch to green. Convergent is between negative 1 and 1. So again, thinking about our number line, okay, negative 1 here, 0, positive 1. Not including those points, but everything in between. All of that stuff is convergent. All right, so in this example, how are we going to tell what this is? Well, we're multiplying by a third. Multiplying by a third, multiplying by a third. It's just the opposite of the divergent term that we just had. Okay, so we're multiplying by a third. So if we begin adding these things together, you're going to start to see a pattern emerging eventually. So 81 is our first term. 81 plus 27, that's 108. Plus 9, so 117. plus 3 is 120, plus 1 is 121, plus a third is 121.333, and if you kept going, if you kept going, then you'd have over 1 over 9, which would be another 0.111. So next term would be 121.444 repeating, and so on and so forth. And you can see that it's beginning to get smaller and smaller, the difference between every term. Okay, so we can probably guess that it's going to be somewhere around 121.5. I'm going to just guess. So, I mean, we can try it again. Just add it again. So 1 divided by 27. Yeah. So the next term is going to be 81 blah, 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 whatever, something like this. It's getting closer and closer to that 0.5. So I'm going to just guess that based off of what we have here. However, the real way to get it, this is just kind of guessing and checking and working closer and closer to that value. The real way to get it is this beautiful, wonderful, amazing, fantastic formula. Okay, so this formula allows us to solve for the sum of an infinite series. Okay, so in our example here, we have 81 on top, 1 minus r. R is the 1/3. So 81 over 2/3, which is like 3 times 81 divided by 2, which I'm just going to plug it in, is 121.5. Amazing. I didn't even check this before the video, and we already got there. Okay, so it's amazing because it shows that, I mean, it's not proof, but it's hopefully becomes quite evident that these two things are actually indeed one and the same. So we can calculate the sum of an infinite convergent series. So here are two example questions. I'm just going to scroll down so you can just barely see the formula. There you go. So using the formula, find the sum of the following series and label each as either divergent or convergent. Pause the video at this point, try it out for yourself, and then press play and see if you get the same answer I do. All right, so first thing you have to do is figure out what is the ratio. And this is timesing by a -1/2. And you can do that over and over again. Yes, that is true. This here is timesing by -2. So the top one is convergent. The bottom one is divergent. All right, so we need to use our convergent sum formula in order to solve for this. So T1 is 6 over 1 minus r, so minus a -1 here. Okay, so this gives us 6 over 3 over 2, which is like writing 2 times 6 over 3, which is like 4. Yep. Okay, so we have the value. We also have if it's convergent or divergent. And this other one, because it's divergent, we cannot use the same formula. What we have to do is we have to say this is undefined. That's all we can do. All right. I hope that this video helps you understand infinite geometric series a little bit better, especially convergent and divergent and that formula. Hope this video helped, and good luck.